Alright, so for the remaining time that I have today, I'm going to be studying Programming, Principles and Practice, using C++, 3rd edition, by Bjarne Stroustrup, the creator of C++. We're going to start at the beginning of the book and continue through up until I think it's a good stopping point for tonight. Okay. So reading through the contents, we obviously have a preface or a preface, and then we have a section 0, notes to the reader. So it talks about the structure of this book, a philosophy of teaching and learning from Bjarne Stroustrup, explanation of the ISO standard C++, and then the PPP. Now this confused me the first time I read this. PPP is the Programming Principles and Practice, and there's support for, well, the book, which is supported code and supported writings. Then we have a quick author biography and a bibliography. And then we proceed with part 1, the basics. With section 1 of part 1, we do a Hello World program, which we talk about programs, the classic first program, which will be the Hello World program. It'll talk briefly about compilation, linking, and different programming environments. And then we move on to objects, types, and values. These objects will have, we will go over briefly input, along with variables, and then input and type, and then those operations and operators that we can use on these types, with these types, assignment and initialization of these values, types, variables, the names that we can use with these variables, types and objects again, along with type safety and conversions from one type to another, and the type deduction auto keyword. In section 3 of part 1, we get into computation, and we talk about the objectives of computation and the tools for it. We talk about expressions, statements, functions, and the vector object, along with some language features. And part 4, not part 4, but section 4, part 1, we have errors. We are introduced to errors. There are various sources. We go into compile time errors, link time errors, runtime errors, or logic errors, along with exceptions, and avoiding and finding errors. In section 5, we'll be writing a program. This program will be thinking about a problem. We'll do a couple things. So it looks like we're going to be writing a calculator program. It'll be talking about how grammar is put into code. And we'll write 2 different versions of calculator. And the token stream and program structure is going to be explained in this writing a program section. In section 6 of part 1, we're going to be completing a program, in which case we're going to be introduced to that with input and output, error handling, negative numbers, the remainder or modulus operator. We'll be cleaning up that code that we write, recovering from errors, so we're probably going to talk about exception handling there, and a little bit more on variables. And then in section 7, technicalities, function, etc. Get that into section 7 of part 1, we're going to be looking at technicalities of functions and etc. So in these technicalities, we're going to be talking about declarations and definitions, along with scope, function calls and returns, order of evaluation, namespaces, modules, which is an important thing, and headers. And then in section 8 of part 1, we're going to be talking about classes. These are user-defined types. We'll be talking about classes and their members, interfacing and implementation of these classes, and then we're going to create a date class, and we're going to involve it, I imagine. And then we will talk about enumerations, operator overloading for these classes, as well as class interfaces. That concludes the content reading for part 1. Now we have part 2, which goes into input and output. It's kind of hard to write a good program that doesn't quite care about any sort of input or output. So, in section 9, which is a part of part 2, we'll be talking about input and output, obviously. The I/O stream model, files, I/O error handling, reading single values, like a value at a time, and then user-defined output operators and user-defined input operators. And then we'll be talking about a standard input loop. Continuing on in section 9, we'll be reading from a structured file. I've done this before with like a .wav file. And then we have formatting and string streams. In section 10, part 2 of input and output, we have a display model. Okay, so we're going to be going into graphics. In this case, we're going to be using a graphics UI or a graphics user interface, a GUI library. We're explaining why we use graphics, the graphics model, an example of which we're talking about coordinate space, different shapes. Shapes is going to, I believe, get us a little further with classes. And then we'll be using these shapes and getting the first example to run. Okay, so I was right about this. So we will be going into more depth and more detail with classes in section 11. We'll be overview of different graphics classes. We'll be talking about points and lines, color, line styles, polylines, closed shapes, along with text, mark, and images. Alright, in section 12, we'll be delving deeper into working with classes with class design, following some design principles. We'll most likely be editing our shape class, and we'll be working with base and derived classes, so in some inheritance, other shape functions, as well as we'll be using this time to talk about the benefits of object-oriented programming. In section 13, we use graphing functions and data. We introduce to these, and then we graphing simple functions with functions and axes, approximation, and graphing data. And we'll be finishing off part 2 with section 14 on graphical user interfaces or GUIs. And we will be talking about user interface alternatives, the next button, a simple window, buttons and other widgets. Widgets is a term I've seen used in the Unreal Engine. An example, drawing lines. We've done that before on many different systems. Many being GDI and DirectX 12. And then we will be talking about simple animation and debugging GUI code. Alright, that concludes part 2. We move on to part 3, which covers data and algorithms. So most likely this will be our data structures and algorithms part of the book. And section 15 goes straight into the most used, I think, data structure, which is the vector. And we'll be going to talk about free store. So we're going to get introduced to this. We'll be talking about vector basics and be getting more into depth about memory, addresses, and pointers, free store and pointers, destructors, accessing elements, and then we're going to a data structure. It's a list, and we'll be working with the this pointer. Section 16 talks about arrays, pointers, and references, something that's pretty important to our very data-oriented programming style. So we have arrays, pointers, references, C-style strings, which, that was fun, always fun, and alternates to pointer use, and example palindromes. Section 17, we talk about essential operations. So I imagine these operations we're going to be using in almost any program ever. Any program we write is most likely going to assume some of these. So we get introduced to these essential operations. We'll be looking at accessing elements, list initialization, copying and moving, and other essential operations. Continuing with this section, we'll be talking about other useful operations and remaining vector problems, changing size, and our vector so far. So perhaps we will be defining our own vector formula or a vector class, which is not an uncommon thing to do. In section 18, we'll be talking about templates and exceptions. So using templates, we can generalize the vector class. We'll be doing range checking and exceptions, resources and exceptions, and resource management pointers. In section 19, containers and iterators, we'll be describing more in detail a method of storing and processing data with different sequences and iterators. We'll be talking about the linked list data structure, and we'll be generalizing the vector class yet again. An example, a simple text editor, along with the vector, list, and string classes. In section 20, part 3, we'll be checking out maps and sets. So we talk about the associative containers with maps and sets. We will create a map class, an unordered map class, along with timing, set, container overviews, ranges, and iterators. So this is something I actually don't quite know very much. I haven't worked with maps very often. I think I've used hash maps, so most likely they're very similar or identical to that, but I haven't done that before. And of course we finish off with glorious algorithms. So we have the standard library algorithms, so the STD libraries, and we have function objects, numerical algorithms, as well as copying, sorting, and searching. So that concludes the contents of Programming Principles and Practice using C++, 3rd edition. And we can move straight to the preface. Alright. I'll grab some coffee. Drinking the good coffee. Alright, so then, as Bjarne Stroustrup would say, programming is the art of expressing solutions to problems so that a computer can execute those solutions. Now, he'll talk about this later on, but programming an art of expressing solutions to problems not only for a computer, but also for people as well. And in our expression of these solutions, or working to express these solutions, we might actually find the solution to these problems. Or we learn a bit more about the problems themselves. Much of the effort in programming is spent finding and refining solutions. Often, a problem is only fully understood through the process of programming a solution through it, or for it. This is what I was saying. This book is for someone who has never programmed before. Now that doesn't quite stick with me because I actually have programmed before, but I'm going to assume that I don't know what I'm doing, which is a safe assumption. But is willing to work hard to learn. Well, this is what I'm doing. Working hard, reading these books, working through them. It helps you understand the principles and acquire the practical skills of programming using the C++ programming language. It can also be used by someone with some programming knowledge who wants a more thorough grounding in programming principles and contemporary C++. Now this more applies to me, because I do have some programming knowledge and I very much want a more thorough grounding in programming principles and contemporary C++. I want as solid as a foundation as I can lay. Why would you want the program? Our civilization runs on software. Without understanding software, you, and me, are reduced to believing in magic, and will be locked out of many of the most interesting, profitable, and socially useful technical fields of work. When I talk about programming, I think of the whole spectrum of computer programs, from personal computer applications with GUIs, with the graphical user interfaces, through engineering calculations and embedded systems control applications, such as digital cameras, cars, and cell phones, to text manipulation applications as found in many humanities and business applications. Like mathematics, programming, when done well, is a valuable intellectual exercise that sharpens our ability to think. However, thanks to feedback from the computer, programming is more concrete than most forms of math and therefore accessible to more people. It is a way to reach out and change the world, ideally for the better. Finally, programming can be great fun. We're going to find that out later. Hello, train. There are many kinds of programming. This book aims to serve those who want to write non-trivial programs for the use of others and to do so responsibly, providing a decent level of system quality. That is, I assume that you want to achieve a level of professionalism, and that's for sure. Very much want to be professional with this. Consequently, I choose the topics for this book to cover what is needed to get started with real-world programming, not just what is easy to teach and learn. If you need a technique to get basic work done right, I describe it, demonstrate concepts, and language facilities needed to support the technique, and provide exercises for it. If you just want to understand toy programs or write programs that can just call code provided by others, you can get along with far less than I present. And I see this happen too often. In such cases, you will probably also be better served by a language that's simpler than C++. So this might be Python, for example. On the other hand, I won't waste your time with material of marginal practical importance. If an idea is explained here, it's because you'll almost certainly need it. So put some more importance into reading everything, as I do. Programming is learned by writing programs. So programming is learned by doing. And I'll certainly support that line of thinking. In this, programming is similar to other endeavors with a practical component. You cannot learn to swim, play a musical instrument, or to drive a car just from reading a book. You must practice. Nor can you become a good programmer without reading and writing lots of code. This book focuses on code examples closely tied to explanatory text and diagrams. You need those to understand the ideals, concepts, and principles of programming, and to master the language constructs used to express them. That's essential, but by itself, it will not give you the practical skills of programming. For that, you need to do the exercises and get used to the tools for writing, compiling, and running programs. You need to make your own mistakes and learn to correct them. There is no substitute for writing code. Besides, that's where the fun is. There is more to programming, much more, than following a few rules and reading the manual. This book is not focused on the syntax of C++. C++ is used to illustrate fundamental concepts. Understanding the fundamental ideas, principles, and techniques is the essence of a good programmer. Also, the fundamentals are what last. They will still be essential long after today's programming languages and tools have evolved or have been replaced. Code can be beautiful as well as useful. This book is written to help you understand what it means for code to be beautiful, to help you master the principles of creating such code, and to build up practical skills to create it. Good luck with programming. We have a little section here talking about previous editions. The third edition of Programming Principles Practice using C++ is about half the size of the second edition. Students having to carry the book will appreciate the lighter weight. I can't imagine. This book is thick as is. If this is double in the second edition, that'll be big. The reason for the reduced size is simply that more information about C++, its standard library, is available on the web. The essence of the book that is generally used in a course in programming is in this third edition, PP3, updated to C++ 20, plus a bit of C++ 23. The fourth part of the previous edition, PP2, was designed to provide extra information for students to look up when needed and also available on the web. So, we have a Chapter 1 on computers, people, and programming. Chapter 11 on customizing input and output. We have a Chapter 22, Ideas in History. A Chapter 3 on text manipulation. A Chapter 24 on numerics, and a Chapter 25 on embedded systems programming, which is something I am interested in, as well as Chapter 26 on testing. With Chapter 27, the C programming language, and the glossary. Where I felt it useful to reference these chapters, the references would look like this: PPP version dot chapter number, or pp2 dot section number and subsection. And we have acknowledgments here. Special thanks to the people who reviewed drafts of this book and suggested many improvements: Clovis L. Tondo, Jose Daniel Garcia Sanchez, J.C. Van Winkle, and Vil Voutilan. Also, Vil Voutilan did the non-trivial mapping of the GUI Graphics Interface Library, or Qt, making it portable to an amazing range of systems. Also, thanks to many people who contributed to the first and second editions of this book, Many of their comments are reflected in this third edition. And here we are, as Section 0, or Part 0, Notes to the Reader. This chapter is a grab bag of information. It aims to give you an idea of what to expect from the rest of this book. Please skim through it and read what you find interesting. Before writing any code, read PPP support, section 0.4. A teacher will find most parts immediately useful. If you are reading this book as a novice, please don't try to understand everything. You may want to return and reread this chapter once you feel comfortable writing and executing small programs. Section 0.1. Actually, I'm going to turn on light here for myself. See how the camera affects it. I think I tested this earlier and it was okay. I'm expecting you to read this particularly because despite the webcam being a 4K webcam, it only takes 4K photos. It doesn't record in 4K. I think it's actually recording in 1080p. So it's a struggle for anyone to read this. Okay. This is why I'm reading it out loud for other people as well as myself to rewatch this. So, Section 0.1, the structure of this book. This book consists of 3 parts, as we've just read from the contents, with Part 1 going through Chapter 1 through 8, so I was calling them sections, so I guess they're chapters. Presents the fundamental concepts and techniques of programming together with the C++ language and library facilities needed to get started writing code. This includes the type system, arithmetic operations, control structures, error handling, and the design, implementation, and use of functions and user-defined types. With Part 2 continuing on with Chapter 9 through 14, we describe we will be described how to get numeric and text data from the keyboard and from files. I'm actually interested very much in from files so that I can write test cases. And how to produce corresponding output to the screen and to files. Then, we show how to present numeric data, text, and geometric shapes as graphical output, and how to get input into a program from a graphical user interface, a GUI. As part of that, we introduce the fundamental principles and techniques of object-oriented programming, OOP. In Part 3, finishing off from Chapter 15 to 21, we focus on the C++ standard library's containers in algorithms framework, often referred to as STL, or the standard template library, I believe it's called. We show how containers, such as the vector, list, and map, are implemented and used. In doing so, we introduce low-level facilities, such as pointers, arrays, and dynamic memory. We also show how to handle errors using exceptions and how to parameterize our classes and functions using templates. As part of that, we introduce the fundamental principles and techniques of generic programming. We also demonstrate the design and use of standard library algorithms such as sort, find, and inner product. The order of topics is determined by programming techniques rather than programming language features, with CC on the left, to ease review and to ask help if you missed a key point during a first reading where you have yet to discover what kind of information is crucial. We place 3 kinds of alert markers in the margins, with CC in blue, concepts describing alerting us to concepts and techniques. This paragraph is an example of that. And then we also have the alert marker AA in green A's for advice. And finally, we have the last alert marker, which is XX in red, describing warnings. The use of CC, AA, and XX, rather than a single token in different colors, is to help where colors are not easily to distinguish. So that could be very helpful with color blindness. I'm a little confused about it, to be very honest. Because why couldn't it be C, A, and X in blue, green, and red? What does having two letters help? It is eye-catching, though. I will admit that. So, section 0.1.1, we talk about general approach to this book. In this book, we address you directly. That is simpler and clearer than conventional, professional, indirect form of address, as found in most scientific papers. By you, we mean you, the reader, and by we mean you, the author, and teachers, working together through a problem as we might have done have we been in the same room. I use I when I refer to my own work or personal opinions. So we have an advice section here. This book is designed to be read chapter by chapter from beginning to end, as we are doing now. Often, you'll want to go back to look at something a second or third time. In fact, that's the only sensible approach, as you always dash past some details that you don't yet see the point in. In such cases, you will eventually go back again. Despite the index and the cross-references, this is not a book that you can open to any page and start reading with any expectation of success. Each section and chapter assume understanding of what came before. So actually I did this. So I know a bit of C++, but I opened up a random page and it actually looked completely alien to me, which told me that, well, reading this book seems a bit more necessary than I originally thought. So each chapter is a reasonably self-contained unit, meant to be read. Oh, geez, I thought. Okay, so each chapter is a reasonably self-contained unit, meant to be read in one sitting. Logically, if not, it's not always feasible on a student's tight schedule. So my schedule is I can get about 2 hours of studying on a weekday and about 6 hours of studying on a weekend. That's a major criterion for separating the text into chapters. Other criteria include that a chapter is a suitable unit for drills and exercises, and that each chapter presents some specific concept, idea, or technique. This plurality of criteria has left a few chapters uncomfortably long, so please don't take in one sitting too literally. In particular, once you have thought about the review questions, done the drill, and worked on for a few exercises, you'll often find that you'll have to go back and reread a few sections. So I've had to do this in a different book, but I imagine we're going to have the same situation. A common praise for a textbook is, it answered all my questions just as I thought of them. That's an ideal for minor technical questions, and early readers have observed the phenomenon with this book. However, that cannot be the whole ideal. We raise questions that a novice would probably not think of. We aim to ask and answer questions that you need to consider when writing quality software for the use of others. Learning to ask the right, often hard, questions is an essential part of learning to think as a programmer. Asking only the easy and obvious questions would make you feel good, but it wouldn't help make you a programmer. We try to respect your intelligence and to be considerate about your time. In our presentation, we aim for professionalism rather than cuteness. We would. How do you even say that? I know you could type it that. We would rather understate a point than hype it. We try not to exaggerate the importance of a programming technique or a language feature, but please don't underestimate a simple statement that is, this is often useful. If we quietly emphasize that something is important, we mean that you'll sooner or later waste days if you don't master it. Our use of humor is more limited than we would have preferred, but experience shows that people's ideas of what is funny differ dramatically, and that a failed attempt at humor can be confusing. We do not pretend that our ideas or the tools offered are perfect. No tool, library, language, or technique is the solution to all of the many challenges facing a programmer. At best, a language can help you develop and express your solution. We try to avoid white lies. That is, we refrain from oversimplified explanations that are clear and easy to understand, but not true in the context of real languages and real problems. So, section 0.1.2, we'll be discussing drills, exercises, and etc. Programming is not just an intellectual activity. So, writing programs is necessary to master programming skills. We provide three levels of programming practice. Drills. A drill is a very simple exercise devised to develop practical, almost mechanical skills. A drill usually consists of a sequence of modifications of a single program. You should do every drill. A drill is not asking for deep understanding, cleverness, or initiative. We consider the drills part of the basic fabric of the book. If you haven't done the drills, you have not done the book. Exercises. Some exercises are trivial, and others are very hard, but most are intended to leave some scope for initiative and imagination. If you are serious, you'll do quite a few exercises. At least do enough to know which are different for you, or which are difficult for you. Then do a few more of those. That's how you will learn the most. The exercises are meant to be manageable, without exceptional cleverness, rather than to be tricky puzzles. However, we hope that we have provided exercises that are hard to understand, are hard enough to challenge anybody, and enough exercises to exhaust even the best students' available time. We do not expect you to do them all, but feel free to try. We're probably going to try anyways. And then we have try this. Some people like to put the book aside and try some examples before reading to the end of the chapter. Others prefer to read ahead to the end before trying to get code to run. To support readers with the former preference, we provide simple suggestions for practical work labeled "Try This" and natural breaks in text. A try this is generally in the nature of a drill, but focused narrowly on the topic that precedes it. If you pass a try this without trying it out, maybe because you're not near a computer or you find the text riveting, do return to it when you do the chapter drill. A try this either complements the chapter drill or is a part of it. In addition, at the end of each chapter, we offer some help to solidify what has been learned. We have a review. At the end of each chapter, you'll find a set of review questions. They are intended to point you to the key ideas explained in the chapter. One way to look at the review questions is as a complement to the exercises. The exercises focus on the practical aspects of programming, whereas the review questions try to help you articulate the ideas and concepts in that they resemble good interview questions. So, terms. A section at the end of each chapter presents the basic vocabulary of programming and of C++. If you want to understand what people say about programming topics and to articulate your own ideas, you should know what each term means. Finally, we have postscript, a paragraph intended to provide some perspective for the material presented. In addition, we recommend that you take part in a small project, and more if time allows for it. A project is intended to produce a complete, useful program. Ideally, a project is done by a small group of people, for example, 3 people, working together, for example, while progressing through the latter chapter of the book. Most people find such projects the most fun and that they tie everything together. Learning involves repetition. Our ideal is to make every important point at least twice and to reinforce it with exercises. So, section 0.1.3, what comes after the book, this book? At the end of this book, will you be an expert at programming and at C++? Of course not. When well done, programming is a subtle, deep, and highly skilled art, building on a variety of technical skills. You should no more expect to become an expert at programming in 4 months than you should expect to become an expert in biology, in math, in a natural language such as Chinese, English, or Danish, or at playing the violin in 4 months, or in half a year, or a year. What you should hope for, and what you can expect if you approach this book seriously, is to have a really good start that allows you to write relatively simple, useful programs, to be able to read more complex programs, and to have a good conceptual and practical background for further work. The best follow-up to this initial course is to work on a project developing code to be used by someone else, preferably guided by an experienced developer. After that, or even better, in parallel with a project, read either a professional level general textbook, a more specialized book that relating to the needs of your project, or a textbook focused on a particular aspect of C++, such as algorithms, graphics, scientific computation, finance, or games. See section 0.6. So I actually have a couple of these books. I have a book called 3D Game Graphics, 3D Game Programming with DirectX 12. So it deals with C++, but it certainly talks about graphics. It's entirely a C++ based graphics API or application programming interface. I also have a book called Programming Windows, which talks about, well, sort of simple GUIs and system integration, so writing programs that interact with the operating system. I also have a book called Numerical Recipes, which I'm not sure what ties into that. But I also have a book on applied computational physics, because I very much want to learn how to do that scientific computation with computational physics. And finally, I also have a book on the Unreal Engine. It talks about game development with some C++ scripting as its backbone. So, making video games. So, eventually, you should learn another programming language. We don't consider it possible to be a professional in the realm of software, even if you are not primarily a programmer, without knowing more than one language. And why? No large programming is written in a single language. Also, different languages typically differ in the way code is thought about and programs are constructed. Design techniques, availability of libraries, and the way programs are built differ, sometimes dramatically. Even when the syntaxes of two languages are similar, the similarity is typically only skin deep. Performance, detection of errors, and constraints on what can be expressed typically differ. This is similar to the ways natural languages and cultures differ. Knowing only a single language and a single culture implies the danger of thinking that the way we do things is the only way or the only good way. That way, opportunities are missed and suboptimal programs are produced. One of the best ways to avoid such problems is to know several languages, programming languages and natural languages. Section 0.2, A Philosophy of Teaching and Learning. What are we trying to help you learn? And how are we approaching the process of teaching? We try to present the minimal concepts, techniques, and tools for you to do effective, practical programming, including program organization, debugging and testing, class design, computation, function and algorithm design, graphics, two-dimensional only in this book, graphical user interfaces, GUIs, file and stream input and output, I/O, memory management, design and programming ideals, the C++ standard library, software development strategies. To keep the book lighter than the small laptop on which it was written, some supplementary topics from the second edition are placed on the web. See section 0.4.1. With these topics being computers, people, and programming, ideals in history, text manipulation, numerics, embedded systems programming, and the C language programming techniques. Working our way through the chapters, we cover the programming techniques called procedural programming, as with the C programming language, data abstraction, object-oriented programming, and generic programming. The main topic of this book is programming. That is, the ideals, techniques, and tools of expressing ideas in code. The C++ programming language is our main tool, so we describe many of C++ facilities in some detail. But please remember that C++ is just a tool, rather than the main topic of this book. This is programming using C++, not C++ with a bit of programming theory. Each topic we address serves at least two purposes. It presents a technique, concept, or principle, and also a practical language or library feature. For example, we use the interface of a two-dimensional graphical system to illustrate the use of classes and inheritance. This allows us to be economical with space and your time, and also to emphasize that programming is more than simply slinging code together to get a result as quickly as possible. The C++ standard library is a major source of such double-duty examples, many even to do triple duty. For example, we introduce the standard library vector, used to illustrate widely useful design techniques, and show many of the programming techniques used to implement it. One of our aims is to show you how major library facilities are implemented and how they map to hardware. We insist that craftsmen must understand their tools, not just consider them magical. Some topics will be of greater interest to some programmers than to others. However, we encourage you not to prejudge your needs. How would you know what you'll need in the future? And at least look at every chapter. If you read this book as part of a course, your teacher will guide your selection. We have a core concept alert here. We characterize our approach as depth first. It is also concrete first and concept based. First, we relatively quickly, with chapters 1 through 9, assemble a set of skills needed for writing small practical programs. In doing so, we present a lot of tools and techniques in a minimum detail. We focus on simple concrete code examples because people grasp the concrete faster than the abstract. That's simply the way most humans learn. At this initial stage, you should not expect to understand every little detail. In particular, you'll find that trying something slightly different from what you just worked can have mysterious effects. Do try, though. Please do the drills and exercises we provide. Just remember that early on, you just don't have the concept and skills to accurately estimate what's simple and what's complicated. Expect surprises and learn from them. We have an advice alert here. We move fast in this initial phase. We want to get you to the point where you can write interesting programs as fast as possible. Someone will argue we must move slowly and carefully. We must walk before we can run. But have you ever watched a baby learning to walk? Babies really do run by themselves before they learn the finer skills of slow, controlled walking. Similarly, you will dash ahead, occasionally stumbling, to get a feel of programming before slowing down to gain the necessary finer control and understanding. You must run before you can walk. And here we have an alert section. An alert token? What did he call this? Alert marker. So we have a warning alert marker here. It is essential that you don't get stuck in an attempt to learn everything about some language, detail, or technique. For example, you could memorize all of C++ built-in types and all the rules for their use. Of course you could, and doing so might make you feel knowledgeable. However, it would not make you a programmer. Skipping details will get you burned, occasionally for lack of knowledge, but it is the fastest way to gain the perspective needed to write good programs. Note that our approach is essentially the one used by children learning their native language, and also the most effective approach used to learn a foreign language. we encourage you to seek help from teachers, friends, colleagues, mentors, etc. On the inevitable occasions when you are stuck, be assured that nothing in these early chapters is fundamentally difficult. However, much will be unfamiliar and might therefore feel difficult at first. Later, we build on your initial skills to broaden your base of knowledge. We use examples and exercises to solidify your understanding and to provide a conceptual base for programming. And here we have an advice alert. We place a heavy emphasis on ideals and reasons. You need ideals to guide you when you look for practical solutions, to know when a solution is good and principled. You need to understand the reasons behind those ideals, to understand why they should be your ideals, why aiming for them will help you and the users of your code. Nobody should be satisfied with "because that's the way it is" as an explanation. More importantly, an understanding of ideals and reasons allows you to generalize from what you know to new situations, and to combine ideas and tools in novel ways to address new problems. Knowing why is an essential part of acquiring programming skills. Conversely, just memorizing lots of poorly understood rules is limiting, a source of errors, and a massive waste of time. We consider your time precious and try not to waste it. Many C++ language technical details are banished to other sources, mostly on the web. See section 0.4.1. We assume that you have the initiative to search out information when needed. Use the index and the table of contents. Don't forget, the online help facilities of your compiler. Remember, though, to consider every web resource highly suspect until you have reason to believe better of it. Many an authoritative-looking website is put up by a programmer novice or someone with something to sell. Others are simply outdated. So, I guess I might be a speaker of a novice, but I don't know. Hopefully, people understand that I don't know very much of what I'm talking about, and I am learning it along with making these videos. In which case, a lot of problems and a lot of errors are going to be made. But we're going to learn from them, and that's the purpose of the videos, to help motivate me to read, and also a reflection of what I'm doing. Also, it's like I'm making my own audiobook for me to read on my way to work, which is very helpful because I can't review in the car because I can't read in the car. And that's a good 45 minutes both ways that I can gain. That's an hour and a half per day. And considering I only have 2 hours of studying every day after work, it's almost a 200% increase in my reading during the week. We provide a collection of links and information on our support website, www.stroustrup.com/programming.html. Please don't be too impatient for realistic examples. Our ideal example is the shortest and the simplest code that directly illustrates a language facility, a concept, or technique. Most real-world examples are far messier than ours. yet do not consist of more than a combination of what we demonstrate. Successful commercial programs with hundreds of thousands of lines of code are based on techniques that we illustrate in a dozen 50-line programs. The fastest way to understand real-world code is through a good understanding of the fundamentals. We do not use cute examples involving cuddly animals to illustrate our points. We assume that you aim to write real programs to be used by real people. So every example that is not presented as specifically language technical is taken from a real-world use. Our basic tone is that of professionals addressing future professionals. C++ rests on two pillars: the efficient, direct access to machine resources, making C++ effective for low-level machine-near programming as is essential in many application domains, along with powerful, zero-overhead abstraction mechanisms, making it possible to escape the error-prone, low-level programming by providing elegant, flexible, and type and resource-safe, yet efficient facilities needed for high-level programming. This book teaches both levels. We use the implementation of higher-level abstractions as our primary examples to introduce low-level language features and programming techniques. The aim is always to write code at the highest level affordable, but that often requires a foundation built using lower-level facilities and techniques. We aim for you to master both levels. So here, the aim is to always write code at the highest level affordable. I'm not that way in my coding, and most likely I'll change, but I'm not that way in my coding. My coding is the least involved implementation. So if I don't have to have a class, I won't use a class. I'll use a structure. If I don't need a structure, I won't use a structure. I'll use the least resources, the least rules, and the least techniques to produce what I think is accurate, complete code. But obviously, this is a difference in what the author aims and what I write. And I'm sort of shooting myself in the foot every time because I'm not practicing this highest level features. And therefore they seem alien to me at times. Section 0. So, Section 0.2.1, a note to students. Many thousands of first-year university students taught using the first two editions of this book had never before seen a line of code in their lives. Most succeeded, so you can do it too. You don't have to read this book as part of a course. The book is widely used for self-study. However, whether you work your way through as part of a course or independently, try to work with others. Programming has an unfair reputation as a lonely activity. It certainly have a huge reputation as a lonely activity for myself. I find programming to be a very alienating and isolating endeavor. Most people work better and learn faster when they are part of a group with a common aim. It is most efficient as well as most pleasant way of making progress. If nothing else, Working with friends forces you to articulate your ideas, which is just about the most efficient way of testing your understanding and making sure you remember. You don't actually have to personally discover the answer to every obscure language and programming environment problem. However, please don't cheat yourself by not doing the drills and a fair number of exercises, even if no teacher forces you to do them. Remember, programming is, among other things, a practical skill that you must practice to master. Most students, especially thoughtful, good students, face times when they wonder whether their hard work is worthwhile. When, not if, this happens to you, take a break, reread this chapter. Look at the computers, people, and programming, and ideals and history chapters posted on the web. There I tried to articulate what I find exciting about programming and why I consider it a crucial tool for making a positive contribution to the world. Please don't be too impatient. Learning any major new and valuable skill takes time. The primary aim of this book is to help you to express your ideas in code, not to teach you how to get those ideas. Along the way, we give many examples of how we can address a problem, usually through analysis of a problem followed by gradual refinement of a solution. We consider programming itself a form of problem solving. Only through complete understanding of a problem and its solution can you express a correct program for it. And only through constructing and testing a program can you be certain that your understanding is complete. Thus, programming is inherently part of an effort to gain understanding. However, we aim to demonstrate this through examples rather than through preaching or presenting. Or presentation of detailed prescriptions for problem solving. Section 0.2.2, a note to teachers. We'll start off with a alert marker for a core concept. No, this is not traditional computer science 101 course. It is a book about how to construct working software. As such, it leaves out much of what a computer science student is traditionally exposed to. Turing completeness, state machines, discrete math, grammars, etc. Even hardware is ignored on the assumption that students have used computers in various ways since kindergarten. This book does not even try to mention most important CS or computer science topics. It is about programming, or more generally, about how to develop software. And as it goes into more detail about fewer topics than many traditional courses, it tries to do one thing well, and computer science is not a one-course topic. If this book/course is used as part of a computer science, computer engineering, electrical engineering, information science, or whatever program, we expect it to be taught alongside other courses as part of a well-rounded introduction. Many students like to get an idea why subjects are taught and why they are taught in the way they are. Please try to convey my teaching philosophy, general approach, etc. to your students along the way. Also, to motivate students, please present short examples of areas and applications where C++ is used extensively, such as aerospace, medicine, games, animation, cars, finance, and scientific computation. Section 0.3, the ISO standard C++. C++ is defined by an ISO standard. The first ISO C++ standard was ratified in 1998, so that version of C++ is known as C++ 98. The code for this edition of the book uses contemporary C++. C++ 20 plus a bit of C++ 23. If your compiler does not support C++ 20, get a new compiler. Good. Modern C++ compilers can be downloaded from a variety of suppliers. See his website with compilers. Learning to program using an earlier and less supportive version of the language can be unnecessarily hard. On the other hand, you may be in an environment where you are able to use only C++ 14 or C++ 17. Most of the contents of this book will still apply, but you'll have trouble with features introduced in C++ 20. Modules, see section 7.7.1. Instead of modules, use header files in this case. In particular, use #include ppp headers.h to compile our examples and your exercises, rather than include #include ppp.h. With ranges in C++ 20, use explicit iterators rather than ranges. For example, sort v.begin, v.end, rather than sort ranges : sort v. If/when that gets tedious, write your own ranges versions of your favorite algorithms. Span. Fall back on the old pointer and size technique. For example, void f int pointer int n rather than void span int s. And do your own range checking as needed. And finally, concepts. Use plain template type name T and hope for the best. The error messages from that for simple mistakes can be horrendous. And section 0.3.1 goes into portability. It is common to write C++ to run on a variety of machines. Major C++ applications run on machines we haven't ever heard of. We consider the use of C++ on a variety of machine architectures and operating systems most important. Essentially, every example in this book is not only ISO standard C++, but also portable. By portable, we mean that we make no assumptions about the computer, the operating system, and the compiler beyond that an up-to-date, standard-conforming C++ implementation is available. Unless specifically stated, the code we present should work on every C++ implementation that has been tested on several machines and operating systems. Alright, my throat's getting scratchy. This is where I'm going to try a cough drop. Let's see if that helps. Oh, of course, it doesn't help if I drop it on the ground. Give it a second to work. Throat's getting really itchy from talking so much. That feels a little bit better. Where I see how I'll be able to talk with it in my mouth. The details of how to compile, link, and run a C++ program differ from system to system. Also, most systems offer you a choice of compilers and tools. Explaining the many and often mutating tool sets is beyond the scope of this book. We might add such information to the PPP support website. If you have trouble with one of the popular, rather elaborate IDEs, integrated development environments, we suggest you try working from the command line. It's surprisingly simple. For example, here is a full set of commands needed to compile, link, and execute a simple program consisting of two source files, myfile1.cpp and myfile2.cpp, using the GNU C++ compiler on a Linux system. The command is C++ space -o space my underscore program space my underscore file1.cpp space my underscore file2.cpp followed by /my underscore program. Yes, that really is all it takes. Another way to get started is to use a build system, such as CMake. However, that path is best taken when there is someone experienced who can guide you through those first steps. So I've used CMake before, but only through tutorial or step-by-step process. I've never used CMake beyond that. So, section 0.3.2, guarantees. Except when illustrating errors, the code in this book is type-safe. An object is used only according to its definition. We follow the rules of the C++ core guidelines to simplify programming and eliminate common errors. You can find the core guidelines on the web, DC. And rule checkers are available when you need guaranteed conformance. So actually, that's important for me. I should check this out. We don't recommend that you delve into this while still a novice. So yes, I will follow that advice and not dive into it, but I very much would like to after reading this book. But consider it reassuring that the recommended styles and techniques illustrated in this book have industrial backing. Once you are comfortable with C++ and understand the potential errors, say after Chapter 16, we suggest you read the information to GC and try one of GC checkers to see how they can eliminate errors before they make it into running code. See section 0.3.3, a brief history of C++. I started the design and implementation of C++ in late 1979 and supported my first user about 6 months later. The initial features included classes with constructors and destructors and function argument declarations. Initially, the language was called C with classes, but to avoid confusion with C, it was renamed C++ in 1984. The basic idea of C++ was to combine C's ability to utilize hardware efficiently, for example, device drivers, memory managers, and process schedulers, KNR, with Simula's facilities for organizing code, notably classes and derived classes. I needed that for a project where I wanted to build a distributed Unix. Had I succeeded, I might have become the first Unix cluster. It might have become the first Unix cluster, but the development of C++ distracted me from that. In 1985, the first implementation of a C++ compiler and foundation library was shipped commercially. I wrote most of that and most of its documentation. The first book on C++, the C++ programming language, was published simultaneously. Then, the language supported what was called data abstraction and object-oriented programming. In addition, it had feeble support for generic programming. In the late 1980s, I worked on the design of exceptions and templates. The templates were aimed to support generic programming along the lines of the work of Alex Stepanov. In 1989, several large corporations decided we needed an ISO standard for C++. Together with Margaret Ellis, I wrote the book that became the base document for C++ standardization, the ARM. The first ISO standard was approved by 20 nations in 1998 and is known as C++ 98. For a decade, C++ 98 supported a massive growth in C++ use and gave much valuable feedback to its further evolution. In addition to the language, the standard specifies an extensive standard library. In C++ 98, the most significant standard library component was the STL providing iterators, containers, and algorithms. C++ 11 was a significant upgrade that added improved facilities for compile-time computation, lambdas, and formalized support for concurrency. Concurrency had been used in C++ from the earliest days, but that interesting and important topic is beyond the scope of this book. Luckily, I have a book on that. I have C++, here it is, C++ Concurrency in Action. Eventually, the C++ standard library added many useful components, notably random number generation and resource management pointers and unique pointer and shared pointer. C++ 14 and 17 added many useful features without adding support for significantly new programming styles. C++ 20 was a major improvement of C++, about as significant as C++ 11, and coming close to meeting my ideals for C++ as articulated in The Design and Evolution of C++ in 1994. Among many extensions, it added modules, concepts, coroutines, and ranges. These changes over decades have been evolutionarily with a great concern for backwards compatibility. I have small programs from the 1980s that still run today. Where old code fails to compile or work correctly, the reason is usually changes to the operating system or third-party libraries. This gives a degree of stability that is considered a major feature by organizations that maintain software that is in use for decades. For a more thorough discussion of the design and evolution of C++, see The Design and Evolution of C++, and my free 3 History of Programming papers 2, 3, 4. Those were not written for novices, though. Section 0.4 PPP support. All the code in this book is ISO standard C++. To start compiling and running the examples, add 2 lines at the start of your code. Import std and using namespace std. This makes the standard library available. Unfortunately, the standard does not guarantee range checking for containers, such as the standard vector, and most implementations do not enforce it by default. Typically, enforcement must be enabled by options that differ between different compilers. We considered range checking essential to simplify learning and minimize frustration. So we supply a module, PPP support, that makes a version of the C++ standard library with guarded range checking for subscripting available. See www.stroustrup.com/programming.html. So instead of directly using module std directly, such as using import std using namespace std, use #include ppp.h. We also supply ppp headers.h as similar versions of ppp.h for people who don't have access to a compiler with good module support. This supplies less of the C++ standard library than ppp.h and will compile slower. In addition to range checking, ppp_support provides a convenient error function and a simplified interface to the standard random number facilities that many students have found useful in the past. We strongly recommend using ppp.h consistently. Some people have commented about our use of a support header for PPP1 and PPP2 that using a non-standard header is not real C++. Well, it is because the content of those headers is 100% ISO C++ and doesn't change the meaning of correct programs. We consider it important that our PPP support does a decent job at helping you to avoid non-portable code and surprising behavior. Also, writing libraries that makes it easier to support good and efficient code is one of the main uses of C++. PPP_support is just one simple example of that. So let me write down this because I want to actually get PPP support working. Because I've only used the import std and using namespace std, as we'll see in chapter 1. And despite the cough medicine helping, it's very annoying to have anything in my mouth when trying to talk. So I don't think I'm going to use it in the future. If my throat hurts, probably time to take a break. Okay, so let's take this, add it to our list of things to do. We'll get to that later. Alright, so we have an alert. Gosh, what is it called? I keep forgetting. Alert marker for advice. If you cannot download the files supporting PPP or have trouble getting them to compile, use the standard library directly, but try to figure out how to enable range checking. All major C++ implementations have an option for that, but it is not as easy to find and enable it. For all setup problems, it is best to take advice from someone experienced. In addition, when you get to Chapter 10 and need to run graphics in GUI code, you need to install the Qt Graphics GUI system and an interface library specifically designed for this book. C_display.system_ and www.stroustrup.com/programming.html. In section 0.4.1, we talk about web resources. There is an overwhelming amount of material about C++, both text and videos on the web. Unfortunately, it is of varying quality. Much is aimed at advanced users and much is outdated. So use it with care and a healthy dose of skepticism. The support for this book is www.stroustrup.com/programming.html. There, you can find the PPP_support module source code, see section 0.4, the PPP.h and the PPP headers.h, also see section 0.4, some installation guidelines for PPP support, some code examples, errata. I don't know what errata means. Hold on. I'm actually going to look that up. Give myself a break anyways. Errata. List of errors. I think I should have known that because I read that. I actually saw that section. Okay, so chapters from PPP2, the second edition of Programming Principles and Practice using C++, were eliminated from the print version to save weight and because alternative sources have become available. These chapters are available at www.stroustrup.com/programming.html and referred to in the PPP free text like this as ppp2.ch22 or ppp2.section 22.1.2. Other web resources. My website, www.stroustrup.com, contains a lot of material related to C++. I have checked the website out a bit, and it does quite have a lot of material. The C++ Foundation's website, www.isocpp.org, has various useful and interesting information, much about the standardization, but also a stream of article and news items. You know what? Let's check that out. Give myself a break, another break. I'm getting quite tired. www.isocpp.org. I'm actually interested in the recent highlights. CPPCon. Registration is now open for CPPCon 2025. September 13th. Oh, holy crap. That is this weekend. In Aurora, Colorado. Ooh, $400 late fee. 5 days. Beautiful Rocky Mountain views. Register. Alright, the fees are expensive. Field trip, what's field trip? Replica Apollo guidance computer. Oh man. I can't afford this. Oh, I want to. What's the student? Full-time students, either at the time they register or at the time the I'm not a full crap. So we're looking at the late prices, and it is huge. That's a lot of money. Oh, that's a lot of money. Okay. It's cool that it's available, because I wanted to go see the Rockies. Honest to God, that sounds like a picture-perfect thing I would go do. But I don't have that money. Trying to get that money. Alright. I recommend cppreference.com as an online reference. I use it myself daily to look up obscure details of the language and the standard library. I don't recommend using it as a tutorial. Let's see that. Because I think I've used cpp.com, but not this one. cppreference.com. Check it out. Huge. Hold on. Let's share this experience. Alright. 26. Alright, compiler supports for CPP 23. Make. What is this? What's feature? And then looks like these are the compilers available. I use MSVC, which, yikes, doesn't appear widely used. Honestly, GCC looks like it would work best. What are these numbers? I guess these are versions of GCC. Looks like I'll be using GCC. I mean, I kind of want all the features. Alright, library features. GCC lib std.c. Oh. Interesting. Alright, let's get GCC compiler, download. Okay. Prerequisites. Oy vey. This looks like a lot. Alright, well, I don't need this. Looks like we only need these. So we need an ISO C++ 14 compiler. I have that with the Microsoft Visual Studio 2022. That has C++ 14. Bootstrap GCC. Versions of GCC prior to 15 allow bootstrapping with ISO C++ 11 compilers. Jeez, what is bootstrapping? Okay, if you need to build an intermediate version of GCC in order to bootstrap current GCC, consider GCC 9.5. It can build the current Ada and D compilers, and also is a version that declared C++ 17 support stable. To build all languages in a cross compiler or other configuration where three-stage bootstrap is not performed, you need to start with an existing GCC binary. Because source code for language frontends other than C might use GCC extensions. Alright, so we need the C standard library and headers. Must be present for all target variants in which the target libraries will be built, and not only the variant in the host C CPP compiler. Platform. Oh, so maybe my eyes are burning out reading this. GNU Flex. What's this? What's this? What's this? What's that? What's this? Oh, it's a lot. Ah! Okay. Here we go. DOS. Nope. Microsoft Windows. Intel 64-bit versions. GCC contains support for x86-64 using www runtime, also available here. Where's the target triple? Other window. I don't want older systems. Intel 64-bit versions. Okay. Here we go. Yikes. You know, getting the GCC up and running on Linux was crazy easy. Alright, so we're going to get this. I think this is what we need. Oh, never Okay. We'll get back to that later. Let's put a pin in that. So git GCC with C++ 20 free support installed. Hell, no, I don't want to switch my operating system just to get those features. Hell, I might have to. Okay. The major C++ implementers such as Clang, GCC, and Microsoft offer free downloads of good versions of their products. All have options enforcing range checking and subscripting. There are several. Okay, so let's check that out as well, because I don't intend to stop using Visual Studio, because I've learned too much to want to leave it so soon. 2021 range checking. Enforcement. Alright, so we have some things to go check out. Alright, so now I'm gonna let's bring that webcam back to full screen. Doop. Okay. There are several websites offering free online C++ compilation. Oh, I keep writing into the book when I use my pencil as a pointer. Honest to God, where is my eraser? No eraser. Jelly bean, though. Alright. So my solution is to press it in, push it down, and then now I have no lead to write with. But a sharp point to look with. For guidance on how to use contemporary C++, see the C++ Core Guidelines. The C++ Core Guidelines, found on https://isocpp/CPP Core Guidelines, and its small support library on GitHub/Microsoft/GSL, except when illustrating mistakes. The GC is used in this book. Alright, let's check that out. Let's just have it available. I know it told us not to study it, but we're going to look at it anyways. GitHub.com ISO CPP Core Guidelines. Oh, not here. What did I write wrong? GitHub.com/ISO CPP/CPP Core Guidelines with an E. Got it. Here we are. The C++ Core Guidelines are a collaborative effort led by Bjarne Stroustrup, much like the C++ language itself. They are the result of many person years of discussion and design across a number of organizations. Their design encourages general applicability and broad adoption, but they can be freely copied and modified to meet your organization's needs. The guidelines themselves are found at CPP_core guidelines. Let's click them. Here we are. Ooh, does it work? Oh. No? Okay. Good and bad examples. This is pretty cool. Is this the only thing, though? I mean, it seems to be pretty big. Here we go. Okay. So let's not get too sidetracked, and let's finish out section 0 so that we can close this off. So, section 0.5. Excuse me. Okay, section 0.5, we have an author biography, and you might reasonably ask, who are you to think you can help me to learn how to program? Here is a canned bio. Bjarne Stroustrup is the designer and original implementer of C++, as well as the author of the C++ programming language 4th edition, a tour of C++ 3rd edition, programming principles and practice using C++ 3rd edition, and many popular and academic publications. He is a professor of computer science at Columbia University in New York City. Dr. Stroustrup is a member of the U.S. National Academy of Engineering and an IEEE ACM and CHM Fellow. He received the 2018 Charles Stark Draper Prize, the IEEE Computer Society's 2018 Computer Pioneer Award, and the 2017 IET Faraday Medal. Before joining Columbia University, he was a University Distinguished Professor at Texas A&M University and a Technical Fellow and Managing Director at Morgan Stanley. He did much of his most important work in Bell Labs. His research interests included distributed systems, design, programming techniques, software development tools, and programming languages. To make C++ a stable and up-to-date base for real-world software development, he has been a leading figure with the ISO C++ standards effort for more than 30 years. He holds a master's in mathematics from Aarhus University, where he is an honorary professor in the computer science department, and a PhD in computer science from Cambridge University, where he is an honorary fellow of Churchill College. He is an honorary doctor at Universidad Carlos Free da Madrid. In other words, I have serious industrial and academic experience. I used earlier versions of this book to teach thousands of first-year university students, many of whom have never written a line of code in their lives. Beyond that, I have taught people of all levels, from undergraduate to seasoned developers and scientists. I currently teach final year undergraduates and grad students at Columbia University. I do have a life outside of work. I'm married with 2 children and 5 grandchildren. I read a lot, including history, science fiction, crime, and current affairs. I like most kinds of music, including classical rock, blues, and country. Good food with friends is essential, and I enjoy visiting interesting places all over the world. To be able to enjoy the good food, I run. For more biographical information, see www.stroustrup.com/bio.html. In section 0.6, we have a bibliography. Along with listing the publications mentioned in this chapter, this section also includes publications you might find helpful. We have ARM, M. Ellis and B. Stroustrup, the Annotated C++ Reference Manual. So I guess that's where you get ARM from, Annotated Reference Manual, Addison Wesley in 1990. And we have A.S., Alexander Stepanov and Paul McJones, Elements of Programming. And we have Anthony Williams with C++ Concurrency in Action, Practical Multithreading. I actually have this book, Practical Multithreading. So let me write that down. I have copy. All right. Then we have a tour of C++. Don't have this book. We have C++ Core Guidelines. I don't have this book. And we have the C++ Standard. I don't have this book, and I probably wouldn't get this book since the standard changes and is defined elsewhere. The Design and Evolution of C++. I might get this book in the future. A History of C++. I am a big history guy, but I feel like I don't think I'm wasting time reading history. It's a lot of time to use on it. Evolving a Language in and for the Real World. That sounds like an interesting topic book. And then we have Thriving in a Crowded and Changing World. History of Programming Languages. So this is the Hoppel History of Programming Languages conferences, and the Brian W. Kernighan and Dennis M. Ritchie, the C Programming Language, KNR. I have a copy. Simula, Begin, Student Literature. Looks like it's German. 1979. And B. Stroustrup, the C++ Programming Language, 4th edition. So I have a copy as well. Alright, so I have a copy of 3 of the books shown. Okay, postscript. Each chapter provides a short postscript that attempts to give some perspective on the information presented in the chapter. We do that with the realization that the information can be, and often is, daunting, and will only be fully complemented after doing the exercises. Reading further chapters which apply the ideas of the chapter and later review. Don't panic. Relax. This is natural and expected. You won't become an expert in a day, but you can become a reasonably competent programmer as you work your way through the book. On the way, you will encounter much information
many examples and many techniques that many thousands of programmers have found stimulating and fun. That concludes part 0 of Programming Principles in Practice using C++, 3rd edition by Bjarne Stroustrup, the creator of C++. And I'll end it off here, and potentially with some extra time, I will start on part 1, the basics. Or, more likely, I'll start on that coming home from work tomorrow. Thank you for watching, and I hope you found this beneficial.